Welcome to the Raw Coding YouTube channel. My name is Anton. In this video for the web scraping series, we're going to take a look at how we can add pipelines to our spiders. We've ran into this problem where our spider is running and slowly accumulating all the data that is collected. If it's going to be collecting for 2, 3, 5 hours, 2 days, infinitely, we're never going to see that data. So what we want to do is stream that data instead of just aggregating it. And for this shouldn't come as a surprise, we're going to be using a strategy pattern. Don't forget to leave a like and subscribe if you're enjoying the video. Any questions, leave them in the comment section. Don't forget to check out the description. I have my C# course out. If you want to learn C#, I highly recommend you go ahead and check it out. With this, let's go ahead and take a look at the video. Here I have a README where essentially I want to go ahead and fix up all of the sites except for the shop because that one is probably going to take a little bit too much work. Let's go ahead, go into scraping. I'm noticing my virtual environment is not on, so let me actually turn that on. There we go. Now in scraping, in wiki, if we take a look at the main, and I'm going to collapse the terminal. First of all, we have an error here with the package missing. So let me just make sure I navigate from scraping wiki to wiki fighters, this module right over here. Another thing that we're not using is this output, so I'm just going to go ahead and remove it. And we can see here that we're invoking some kind of handler and we're getting the results back. So first of all, let's go ahead and add this streaming motion. And we already know how to do this. We use the yield keyword. And since the underlying handler is going to be streaming stuff to us, we're just going to stream from there as well. So yield from that handler. We can remove the results here and then go to each individual handler. Here, let's go into get opponents. At the top function, what we're doing over here is we're getting many opponents and then appending fighter information. So all we have to do here is yield O and then remove the opponents here. And then this becomes a generator, which yields all of the opponents eventually. For get opponents, now this will need to yield stuff as well. Here we have the final results array. Let's go ahead and remove it. The appending over here, we will remove it and again use the yield keyword, remove the opponents. And then for the get fighter info, I think we're okay using the return fighter info. I don't know about this space. Let's clean this up. This is where the fighter info is added, and yeah, that's okay to return. If we go to main py, we will see that this get fighter info here won't be yielding, well, because it's just returning a single piece of fighter info information. So for this, we can count this as an edge case and basically say, look, we will just do something along the lines of this, execute the request right over here, take response text, place it into get fighter info and yield this. Straight after this, we will return because we don't want to continue execution to down there. Let's remove the unused imports at the top. We will close main py, we will close wiki fighters, we will leave the readme and we're going to go into run.py. In here, what we have is the runner and then we have the run scraper, which is going to run our scraper. Here we get the default function, we execute it, and we were planning to return all of the final results over here. Instead of just returning the results, what we really want to do is whatever is going to run the scraper kind of reach the hand into the scraper, supplies a strategy, and that's really the motion of how I envision it. And what we want to do is feed all of the items that we're collecting into this hand, and it's going to pick it out one by one. So the hand, we're going to call it pipeline, and into this pipeline, we're going to be sending stuff from the generated results. So instead of return, let's use a for loop. So for item in entry point, everything that's generated is going to go down into this pipeline. We now have to think about the parallel use case as well. So we're going to put the pipeline down into here and here. This is where we submit the initial work, and here we try to get the results. If we go into get results, we are seeing here that we're first trying to complete all of the work, and all of the work that we're doing is executing the tasks and then also processing all of the items that those tasks are generating. After all of that is done, we then go ahead and aggregate all of the items. In this case, we can stop aggregating all of the items and then accept a pipeline in the constructor, remove the results queue and place a pipeline here instead. And every single time we collect something, we actually want to send it down into this pipeline. So again, self pipeline and put the n in there. N as in, well, the item that we have collected. Instead of get results, perhaps what we want to call this is wait to complete now. We'll take this function, wait to complete, place it over here, and then remove the return. Take the pipeline and pass it in the constructor. Okay, so we managed to propagate this pipeline, which is essentially a function which is just meant to be accepting results, right? So if we go into scraping CLI and main py, here we can see that we are not passing a pipeline and we actually want to pass some kind of pipeline, okay? What is this pipeline actually going to be? For now, let's say we will assign it to none, and we're going to remove this malarkey over here where we're saying get all of the results and then dump them to a file. What we instead want to do is slowly stream the results to file as we're getting those results. So let's go into dump to file. Here we have it. And instead, we're going to define a class file pipeline. We'll give it a body and start defining things like the constructor. Here we will give it a file name, so file name, and by default, let's say if you don't supply a file name, we'll just name it to output JSON. Let's assign this field, so file name equals file name. If we take the file pipeline now, go to main py over here and create the pipeline. Make sure that we're getting it from output, and a better way to really write this is say scraping output import file pipeline instead of all of this. Don't grab output from here, remove the output here, and then remove the dump. So we have prepared our file pipeline. What we want to do is now, well, start writing to file. And the pipeline over here isn't really a function. We're creating an instance of a class and then passing down this instance. Instead, let's create a function on here. So def process, and this is going to process some kind of item. For now, let's say we will put a pass here, pipeline, and on the pipeline, grab the process function, and that is where the items are going to go. Now, before items start going in, we want to open the file, and after the items have finished going into the file, we want to close the file. What's the best way to do this? Well, the best way to do this will actually be with a with statement. So we want to say something like this: with file pipeline as pipeline. And then we're defining the space for which the pipeline exists, and we can remove this variable. In order for this syntax to work, we will need to add a couple of special parameters. Def enter, and then again, a self will be passed. I don't think there will be any parameters over here, or at least that I can't remember. And by the end, we want to return self. So in main py over here, as we're creating the file pipeline, what gets assigned to the pipeline variable is the result of the enter function. Now, as we enter, what we want to do is we want to open a file. Here we can say open with self file name, and instead of the W flag, we're going to use the A flag, and that is just going to start appending things to the file rather than overwriting everything. We will use the same encoding right over here. From the beginning, I think it's best to make sure that this is at least initialized to none in the constructor. And then we need a pair function to enter, which is called exit. And this is going to focus on closing the file. This doesn't need to return anything, and exit is going to be called when we exit the with block. Now, coming back to the output, as we open the file, what we want to do is go to self, file, and not file name, so file, and then write to the file, an opening brace, and let's say a new line. So we're opening a JSON array, and then all of the items will go line by line into here. We'll then take this and close off the array as we're closing the file. So let's go ahead and reverse this. Then when we're processing the files, we can take JSON, dump the item to self file stream, remove the pass. There are a couple of things missing from here, but we'll figure it out in just a second. Let's take the dump to file. We can go ahead and get rid of it. We're gonna go to the README over here. We're gonna take the command to collect stuff from Khabib, open up the terminal, run the application. Here we're gonna see exit crash. However, output has collected some things. First of all, with the output, we will see it is adding items. It is not putting them onto new lines, and it is not putting commas. So if we go to output, let's go to process right over here. After we have saved an item to the file, we are going to go to the file and we're going to write comma and again a new line, so stuff gets placed onto new lines. So 4 parameters were given to exit. We don't really care what those parameters are. Let's go ahead and just capture all of them. So args and kwargs, and just ignore them. Okay, let's take output JSON and we're going to remove it, rerun the scraper. Take a look at output JSON, and there we have it. So I'm going to collapse the terminal and we'll see commas everywhere except for the last line. So the last line over here, perhaps you don't want this comma over here. One of the easiest things to do for this is say, is this the first item that we're writing? So first, from the beginning, this is going to be true. And then if self first, if this is the first time around, we kind of want to ignore stuff and just output the JSON item. However, because the second time it's no longer going to be the first time, we're going to flip first to false. And then otherwise, we are going to append the comma and the new line. Okay, so we're dumping the item, and if there is going to be one more additional item, that is when we put a comma, new line, and put the additional item. And we basically make sure that the last item does not have a comma and the new line. So if we rerun the application here, we can see the previous output and then no awkwardness at the end right here. Okay, so that's the output for wiki. That looks to be working, and here's essentially our item processor. This is where you can take a personal challenge and implement a array aggregator, which is going to enter, create an empty array, process will put items into array, and then exit, I don't know, might dump the file. So you're essentially aggregating items instead of writing them to the file one by one. Okay, since wiki is working, what I'm going to do is I'm going to delete shop because the website has changed, the scraper is broken, it's going to take a while to fix it, so we're not going to go over it. Let's close everything, and the next on the list are the blogs. So if we go to the blogs main, again, what we want to do is just start yielding. So let's take the results, remove them. Instead of append, we will yield. So new line over here. Remove the last brace and everything else looks good. This awkward space, let's get rid of that. Okay, open up the terminal, let's execute this. And there we have it. So 25 posts, take a look at output JSON, and there we have our data. So again, that looks to be working. If we take a look at BBC Food, main pie, we are running tasks over here. If we go into collect recipes, actually stuff should be working here, and we have the parallel flag. Okay, I think this should just work without any problems. Let's take a look at the output JSON, blogs, and then all of the pizza recipes. Okay, yep, that is working. And then CoinDesk, let's take a look at CoinDesk. So main pie. What we're doing over here is we are stuck in a loop and then we're polling. And we're also aggregating the results into a dictionary. So let's actually get rid of the dictionary, get rid of these results. We'll get rid of these array initializations, and then instead of appending to arrays, we are just going to yield and remove this brace on the end. Now, there is a delay over here with a while loop. So what I'm going to do is, well, I'm going to run this and cut the video. So let's take this, run. Actually, one thing that we can take a look at here is, as this is running, we don't see updates in the file, right? You can use this as a diagnostics tool if it's going to slowly append stuff, but it isn't. So let's actually take a look at this. I'm gonna stop the scraper. We have 4 points of data that we collected and the array. Let's remove everything, and the way that you get this output updated more often is if we go to output, on the file that we're opening, you can set the buffering to, let's say, something, I don't know, 128. So every 128 bytes that reach the buffer will essentially get flushed to file, and then the buffer will be reused. This way we will actually see stuff being written to the file a little bit more often. So let's run this again. We'll go to output.json and wait for the stuff to be written here. Okay, I had to look it up. Basically, you want to set the buffering to 1, and now as the collection is running, it's going to start appending stuff to it, okay? So let's go ahead and see it again. There we go. So, I mean, the view of the file doesn't update instantaneously, but as you ping between the files, you will see the buffer being updated. Okay, so there it goes. Let's bring back the terminal. I'm gonna actually exit here. Let's clear this and let's fix up the last big boy. So coin market cap, this is a little bit of a hard one, and generally anytime you work with sockets, it's going to be a little bit hacky. So first of all, let's go ahead and rename hello to something sensible. Say start WebSockets connection. This can also be called start collecting. And I noticed I don't have WebSockets because I haven't added it to my requirements and I haven't reinstalled it. So pip install -r scraping requirements. And I was meant to use -r, not -e. Cool, so now that I have the requirements, I should have WebSockets over here. Okay, start WebSocket connection. That is going to start collecting, and this is a blocking operation. We don't want to return anything from here, and we don't want to return the results that we're going to be aggregating over here. We don't want to be appending nothing. What do we do with the coin data? Now, since this is going to be blocking, we want to unblock it. So let's actually go into runpy. We're going to take the thread pool executor, place it over here. So with thread pool executor, get this in here, and then as executor. I know it's a little bit awkward that I'm just writing at the very bottom of the screen, but on the executor, we want to submit some work. We're just going to wrap this in a lambda. So a lambda is just an anonymous function, and we're going to execute this work. So this whole asynchronous malarkey that is going to be happening, we're just saying, you go work over there, okay? And since it's going to be working somewhere over there, we actually want to be able to communicate with it. The way that we do that is, well, we do it through a queue. So let's get a queue in here. We're going to import queue from concurrency, or I'm pointing to the wrong place, from queue import queue. Let's take this queue and just pass it down into start WebSocket connection. We can accept a queue and we can actually indicate that it is this queue. So when we are creating our coin data, we can go ahead and put it inside this queue. Okay. On the other end, we are going to have a future. And while the future that we have over here is done not, while not done, and queue empty not, so not empty, bot. We want to go ahead and keep trying to read from the queue. So queue get item. And at the end, we want to say that task is done, okay? With the item that we have over here, let's go ahead and yield it from the function. So now our default function looks as follows. We start off a process somewhere in the background. It is going to churn away and put stuff onto the queue, which we're going to listen from and then yield from it. And then later say that we have actually processed this item. What can potentially happen over here? Let's say the last item is being submitted over here. It gets put into the queue, and then we are on this instruction over here. While we are going from here to the while loop and then trying to exit this coroutine that is spawned over here, potentially we will get the item in the queue, we will yield the item, we will acknowledge it, and we will loop around. So there is potential for a race condition right over here. Hopefully you can see it, how in between the space over here and the end of the function and the looping around over here. If we loop around, the future is not going to be done. The queue will perhaps be empty, but this condition will already fail at that point. So we'll be stuck trying to read something from the queue. If we hover over get, perhaps we want to supply a timeout. Well, we'll see that we will be blocking for some kind of time, and then an empty exception will essentially be raised. So let's go ahead and supply a timeout. We will say 10. And we will say try, do this operation over here, and actually task done. Otherwise, accept empty. Let's see how many empty exceptions there are. Actually, a good one. So empty exception from the queue namespace, or can give this a body and say continue. At this point, we will jump to the beginning of the loop, and then this logic should essentially take care of it. Okay, let's go back to the README, take scrape coin market cap, place it over here. And let's take a look at output JSON. Looks like we got an exception, so let's come back to main.py. What does empty do again? Not sure why it wants this self parameter when the queue itself was meant to be the self parameter. Let's take the queue. We will move it into this with statement right over here. And actually one thing I realized is we want to await the future at the end. Okay, so future and then result. And this is actually meant to say or. If future is not done, we want to keep processing. If future is done, but there are still items on the queue, we want to, well, drain those items. And actually, I'm just realizing that I haven't invoked the constructor on the queue right over here, so that will definitely help. Let's open up the terminal and rerun. Okay, and there we go. So data is, well, slowly being collected. There we go, some more. And I'm pretty confident it's working. I'm gonna leave this running and just make sure that it shuts down gracefully. And there we have it. Looks like it actually exits gracefully. So this will be it. Thank you very much for watching. Hopefully you can now understand that whatever scraper you have running, you take that place in between the scraper generating items, take all of those items and push it through this pipeline, which can then, well, aggregate it into a list, aggregate it into a file, put it in a queue somewhere else, send it to an API, send it to Google Drive, to a CSV file. The possibilities are endless. If you enjoyed the video, don't forget to leave a like, subscribe. If you have any questions, make sure to leave them in the comment section. If you would like access to the code, come support me on my Patreon. A very, very big thank you to all of my current Patreon supporters. Your help is immensely appreciated. As always, thank you for watching. I'll see you later.